So students, today my topic will be on significant figures. So I am giving you some rules for the significant figures. Later on, it will be easier for you to understand them. See here, all non-zero digits are significant. All non-zero means here they are all non-zero digits. So when you count the significant figures means each of the non-zero, they are all non-zero, so all can be counted for. How many figures are there? 1, 2, 3, 4. So this is 4 significant figures. Now if you take all zeros, rule number 2, all zeros occurring between two non-zero digits are significant. So here there are two non-zero digits. Example, you see 4 and 9, they are non-zero. So in between there are two zeros, so you have to count them. That means 1, 2, 3, 4 is the significant figure for this. Even in this case, you have 4 and 9 as non-zero. In between you have two zeros. So even if there is a decimal, this counts to 4 significant figures. Rule number 3, all zeros to the right of the last non-zero digits are not significant. That means this side you have 2, all non-zero digits is 2, last non-zero digits, and you have zeros after that. So you need not count these two zeros. So significant figure for these 4 numbers will be 1, 2 only. So it has only 2 significant figures. Next you have for a number less than 1. So this number is less than 1. Zeros on the right side of the decimal point. So this is the decimal point and this 0 is to the right of the decimal point, but to the left of a first non-zero, that is it is left of 4, here it is left of this 0 is to the left of 5. So less than 1, for a number less than 1, zeros to the right side of decimal, this is the right side of decimal, these are to the right side of decimal, they are before a non-zero digit, left of non-zero digit, so they are not significant. That means this will not be counted for. So significant figure will be for only this and this, that means 2 and 4 and 6, 2. Here 1, 2, 3, so 3 significant figures. The trailing 0 in a number with a decimal point are significant. So here 8.2, after 0.2 there are trailing means in the end, zeros after a decimal point. There is a decimal point and the last zeros are significant. So there will be 4 significant figures. Next we have our next rule, that is the zeros, the digit 0 is conventionally put on the left of a decimal for a number less than 1 is never significant. So you can see here how 0 is put to the left of 0.9. So left of a decimal, it is not significant. That means this will have significant figure. How many significant figure? This will have 3 significant figures, 9, 8 and 7. That means this zeros place will not be counted. 1, 2, 3. Then the number of significant figure do not change even if the expression is expressed in some other system. Here it is centimeter, units are different, centimeter, kilometer, millimeter, but we will take the rule as common rule only. Here also 1, 2, 3, 4. Here also this zeros to the right will not be counted. So significant figure will be 1, 2, 3, 4, even if it is kilometer. Here millimeter, but these are all non-zero numbers. So 1, 2, 3, 4. They all have 4 significant figures. So these are the rules for finding the significant figure. Now there is another rule that is called rounding off. You can round off the digits. How can the digits be rounded off? So that rule let us do now, the rounding off the measurement. Rounding off. So how to round off the measurement? Let us see how to round off the measurement. You can round off the measurement. So there are also certain rules. If a digit is to be dropped is less than 5, then preceding digit should be left unchanged. So this one, this rule also I will give you, that is, if a digit is to be dropped is less than 5, that means, for example, first rule, if you have 8.72, okay, if you have 8.72, you can round it off to rounds of 2. Rules I'll write for you afterwards. 8.72 rounds off to 8.7. Why? The rule is that the digit to be dropped is less than 5. So that this is 2. 2 is less than 5. So it can be round off to 8.7, because the digit to be dropped is less than 5, then preceding digit should be left unchanged, that is, it will remain as 8.7. Number 2 rule, if a digit to be dropped is greater than 5, okay, here you write down, if digit to be, this is rule 1, okay, digit to be dropped is less than 5, then preceding digit is left unchanged. This is your first rule, example is here. Second rule, if digit to be dropped is greater than 5, is greater than 5, if it is greater than 5, is greater than 5, then preceding digit, preceding means before, preceding digit is increased by 1. That means 8 point, if it is 8.78 rounds off to how much? 8.8. 8.8 rounds off to 8.78 rounds off to 8.8. This is your second rule. Now comes the third rule. What is your third rule? If digit to be dropped is 5 followed by digit other than 0, then preceding digit is raised by 1. So example 7.351. So digit to be dropped is followed by digit other than 0. So you see here 0.3. So you are to drop 5, say, and it then other than 0, then it is followed by 1. 5. So next number to 5 is 1. So it is not 0. Then this number will be increased by 1. Rounds off to 7.4. It rounds off to 7.4. Number 4. If a digit to be dropped is 5 followed by 0, then preceding digit remains unchanged if it is even. Example, 3.45 rounds off to how much? 5. In the digit to be dropped is 5 or followed by 5. It is followed by 5, then preceding digit remains unchanged. If it is even, so this is even, so it will remain as 3.4. And last rule, if digit to be dropped, if digit to be dropped is 5 or followed by 5, followed by 5 or followed by 0, then preceding digit is increased by 1 if it is odd. So that one was if it is even, and this is if it is odd. That means, example, if it is 4.35, this is odd, followed by 5. This is then followed by, it is the digit to be dropped is 5 or followed by 5. 5 followed by 0 or 5 followed by 0, then what will happen? Preceding digit will increase by those. So this rounds off to 4.4. Here it remains unchanged if it is even. Here it is odd, so it is increased by 1. Increased by 1. So that's all about the significant figure. Thank you.